Titration curve part 3. So part 3 of this question said what would be the pH after adding 12.5 milliliters of sodium hydroxide. So now that's what we're going to do. Adding 12.50 milliliters of sodium hydroxide. So this is from adding 12.5 total milliliters of sodium hydroxide. This isn't 12.5 more milliliters of sodium hydroxide from part 2. So again, in here in my burette, I have my 0.30 molar sodium hydroxide, and down here in my flask, I have 25 milliliters of my 0.30 molar weak acid HA, or it's actually hydrofluoric acid HF. So now I am going to add 12.50 milliliters of sodium hydroxide into this. So now I'm going to also change my volume. My total volume is going to be 37.5 milliliters because I'm adding 12.5 milliliters of the sodium hydroxide. So we are going to do the same thing as we did before, and we are going to first, we are going to determine how many moles of weak acid are in the flask, and we are going to see how many moles of sodium hydroxide are in the flask. And then I'm going to see what is the chemistry that's happening. What type of chemistry is happening? Okay, so how many moles of HA are in the flask? So this is the same as step 2. Because the number of moles of the weak acid aren't changing. This is back to the beginning, back to step 2. So we said we had 0.025 liters of a 0.3 molar solution. So I have 0.0075 moles of weak acid. How many moles of sodium hydroxide are in the flask? Okay, so I have 0.01250 liters, 12.5 milliliters, and I have 0.30 moles in 1 liter. That means I have 0.00375 moles of sodium hydroxide in my flask. Okay, so now let's see what's happening with the chemistry. So I have 0.0075 moles of HA plus 0.00375 moles of sodium hydroxide. So the 0.00375 moles of sodium hydroxide will neutralize 0.00375 moles of the weak acid and produce 0.00375 of the conjugate base, just like we said in the neutralization reaction. When it is neutralizing the weak acid, it's also producing the conjugate base, and leave 0.00375 moles of HA remaining. Okay, that's kind of confusing. So we have 0.0075 moles of HA. the 0.00375 moles of sodium hydroxide is going to be totally used up. It's totally used up. It's going to neutralize this whole amount, neutralize 0.00375 moles of the weak acid. So 0.0075 minus 0.00375 is 0.00375. It's half of it. And it's also going to produce 0.00375. So now what we have is the same situation as before. We have a buffer where we have 0.00375 moles of conjugate base and 0.00375 moles of weak acid. So we have a buffering system again. We need to figure out the concentrations. So we're going to use the number of moles to solve for the concentrations. Concentration of weak acid, concentration of conjugate base. So I have 0.00375 moles of weak acid. My total volume is going to be 12.50 12.50 plus 25. That's going to be 0.0375 liters. 37.5 milliliters, 0.0375 liters. This is going to give me a concentration of 0.1 molar. So now let's do the same thing for the conjugate base. I have the same number of moles of conjugate base. So I have equal concentrations of conjugate acid and conjugate base here. So let's see what that makes the pH. So I'm going to use the Henderson-Hasselbalch equation to solve for pH. Again, the Henderson-Hasselbalch equation is pH equals pKa plus the log of base over acid. So I'm going to do pH equals pKa. pKa we determined previously to be 3.18 plus the log of the concentration of A minus, 0.1 molar, divided by the concentration of HA, 0.1 molar. You'll notice that this is going to go away. This whole thing is going to go away. This is 0.1 divided by 0.1 is 1. And now what is the log of 1? 0. So anytime you have a buffer that has equal concentrations, acid and base, it makes this whole term go away, because whatever this concentration is, as long as it's the same, it's going to be 0, because the log of 1 is 0. So that means the pH just equals the pKa. So what is true is that in a buffer, the pH equals the pKa when you have equal concentrations of weak acid and conjugate base. So here, pH equals 3.18. So after adding 12.5 milliliters of sodium hydroxide, the pH inside our flask is 3.18. So back to our titration curve, I've added 12.5 milliliters, and my pH is going to be 3.18.